With Chapter 4, we continue examining elements and the periodic table. Atoms are the smallest particles of an element. The word atomos means uncuttable. And the idea that matter is formed of smaller pieces and could not be cut into smaller parts came about the year 430 BC. The idea of atoms as we understand them today began to develop around the 1600s. The atomic theory is a theory that grew out of a series of models that developed over a series of time and experimental evidence. And as more evidence was collected, as with many discoveries in science, the theory and models were revised. So now let's take a look at some of the earliest theories to the understanding that we have of atoms today. So we can begin with Dalton's atomic theory. And with really only a few changes, the theory is still accepted today. Dalton's idea has four main components: that all elements are composed of atoms that cannot be divided, that all atoms of the same element are exactly alike and have the same mass, atoms of different elements are different and have different masses, an atom of one element cannot be changed into an atom of a different element, meaning that atoms cannot be created or destroyed in any chemical change, only rearranged. And finally, that every compound is composed of atoms of different elements that are combined in a specific ratio. Next, we'll examine Thomson's model. At the start of the 20th century, scientists discovered that atoms were actually made of smaller parts, that atoms contain negatively charged particles, but because atoms have no electrical charge, they also assumed that atoms had to contain a positive charge because a positive and negative cancel each other out. Thomson proposed that the atom was like a ball of positive charge that had negative charges scattered throughout. And an analogy for this model is that of a blueberry muffin. You can think of the bread part as the positive, sprinkled with blueberries within, which is an overall individual negative charge. With Thomson's model, the discovery of something called electrons, which are the negatively charged particles, was found. Moving forward, there's Rutherford's model. And Rutherford actually was a student of Thomson, and in 1911, he found evidence to counter Thomson's model. He created an experiment in which he aimed a beam of positively charged particles at a thin sheet of gold foil. You can see down here, a positive charge at a thin gold sheet. Some of the particles were deflected by the gold foil, but most of them passed through the foil. And you can see here that most of them passed through, but some of them were deflected. And he used this to infer that the atom's positive charge is clustered in a tiny region in the center. This is when the idea of the nucleus of an atom was founded. The belief is that the nucleus is at the atom's center region and is clustered with protons, or positively charged particles. He also knew from other experiments that electrons had almost no mass, so he supposed that nearly all of the atom's mass had to be located in the nucleus. He was able to come up with this idea because, as with magnets, positive and positive repel. When positive beams were shot at the gold foil, the fact that only in certain locations were they reflected or deflected back, that those had to be the centers of the positive, rather than the overall gold sheet being positive, as was suggested in Thomson's blueberry muffin ideal model. In 1913, Bohr entered the scene and showed that electrons only have specific amounts of energy, which leads them to live in certain orbits, like planets orbiting the sun or layers of an onion. So his idea added to the model that there was still this positive center nucleus where all of the protons were, but that the electrons, rather than being randomly sprinkled, actually orbited in specific energy levels around the nucleus. The cloud model, which came about in the 1920s, changed the perspective toward electrons. The cloud model supposes that electrons can actually be anywhere in a cloud-like region around the nucleus, and that it's the electron's movement that's related to its energy level. So it still expects that there are different energy levels, but rather that they're not moving in an exact perfect orbit. Here, electrons of different energy level are likely to be found in different places. We will have the opportunity to make several different formats of models, but a really good thing to do now is to draw a picture to help us remember each of the 5 major models we talked about. In the first, Dalton believed the atom just to be kind of one singular, undividable thing. And we moved into Thomson's, and so I'm drawing, it's the blueberry muffin idea, so drawing one overarching positive to show that this color is representing the whole thing as positive with sprinklings of negatives throughout. Rutherford introduced the idea that actually there was a center that was positive, the nucleus full of protons, with electrons circling around the center nucleus. Bohr added in the idea of energy levels and orbits, so that the center was still the positive nucleus, but that there were electrons orbiting in energy levels around that nucleus. And finally, the cloud model still retains the idea that there are energy levels, but rather that the electrons are moving in a cloud-like fashion around the center nucleus. Additionally, we now know that there are also neutrons, and these are particles with no electric charge and nearly the same mass as a proton, and they're all found, protons and neutrons are found in the nucleus of an atom. The modern atomic model, at the center of an atom is a tiny massive nucleus which contains protons and neutrons. Surrounding the nucleus is a cloud-like region of moving electrons. The number of protons is equal to the number of electrons, which is why it has no charge, and it is neutral. And the number of neutrons does not have to equal the number of protons. So you can see here in this image that there is a central nucleus blown up here to have both protons and neutrons, and a cloud of electrons. That 6E with a negative is representing 6 electrons circling around.